Hi, my name is Xing An, and this is the video quiz tutorial for Chapter 16, problem number 43. This is the problem statement. A thin-walled, hollow circular glass tube, open at both ends, has radius r and length l. The axis of the tube lies along the x-axis, with the left end at the origin. The outer ends are rubbed with silk and acquire a net positive charge q distributed uniformly. Determine the electric field at a location on the x-axis, a distance w from the origin. Carry out all steps, including checking your result. Explain each step. So that is the figure. So what we're going to do is that we're going to treat the glass cylinder as a series of concentric rings. So here is the formula for that. E is equal to 1 over 4 pi epsilon naught qz over r squared plus z squared raised to the 3/2. So we're going to be using that equation. But first, because we're finding it anywhere along the x-axis, we need to determine the location and the charge density. So step 1 is determine the charge density because we are going to be taking the integral later. So we have delta q over delta x is equal to total charge, which is q, over total length L. So to find the delta q, we're going to multiply the delta x over. So our delta q is equal to q over L times delta x. Step number 2, we're going to find our vector. And in the x direction, it's just w, this length w, minus x, which is going to be anywhere along the x-axis. We're also going to set our origin at the left end of the cylinder. So we find that our r vector is w minus x, comma r, comma 0. Afterwards, we're going to plug it into the formula. And this is the formula that I showed in the slide, 2 slides before. And we're going to plug this in. So this Q is our total charge, but however, we're going to plug in our charge density. So afterwards, we get our Z as W minus X, and we plug in W minus X over here. So then we need to substitute the delta Q that we found in step 1. So after we substitute everything, this is what we're going to get. And so we can later on we can pull out the ones that are not variables, the constants, which is 1 over 4 pi epsilon naught times q over L. And then we're going to take the integral of everything dx from 0 to length L. And then after I took the integral over here and I found that I had to use u substitution, where our u is equal to w minus x squared plus r squared. And so after you take the integral and you substitute and everything, this becomes your final answer right here. That's it. Thank you so much for watching.